This conference will now be recorded.
So guys, once again, this is Ishant on behalf of Auribises. I hope you are all doing a good programming structure with your current days. So I have Arshdeep, Gagan, Hitali, Kamal Hunjan, Manmeet, Navjot, Pradeep, Roopkaval, Sahib, Sahil, Sarthak, Shashi, Shifali, Shivani, and Tanya with me as of now. So guys, today we're gonna step further and we're gonna see how we can write our program to build the neural network, right? So let me quickly come here with the data set first of all. So we got this data set on which we are trying to work on. So this is your seeds.csv from x1 to x7 and y is the target, right? So you got this 1, then the 2 and then the 3, right? So this is how we have the y as target. So 3 different classes, so 1, 2 and 3, and this was our neural network built so far yesterday. So I'm just gonna shift this program to a newer file. So let's write this session as session number 60. So guys, we got the dataset helper. So this is your helper class to read a data set and normalize the data. So that was the first job of this helper class. So you want to read a CSV file and you want to normalize the data, you can do that, right? Second thing was create your X, Y, and classes. The third step which we have to come up and understand is this k-fold cross validation, right? So how basically you are going to come up and make folds of the data set. So these are the three responsibilities. So it's gonna be helper class, it's gonna create X, Y, and classes from the data set. And thereafter it's gonna make folds of the data set, right? So this is, I hope, clear to everyone, right? How the thing is working for us. So this is a k cross validation algorithm, right? Where what you are doing is you are sort of randomly breaking your data set into these particular folds, right? So this is the number of observations and these are the folds which you are expecting. So in our ANN, what we did so far, right? So we have written this summation function, right? Which is going to be a dot product of your input weight in the inputs and the weights which you will pass here. We got a sigmoid function, which is 1 by 1 plus e power minus x, right? We got a derivation of sigmoid function, which is going to be sigmoid into 1 minus sigmoid, right? So this is a transfer function basically. Then what is one hot encoding here? We haven't written that part. What is update weights, feed forward, feed backward, and fit and break, right? So this we haven't done. But my ANN contains an input, output, hidden layer, and a network, right? So today I'm going to somehow work on this building the artificial neural network. So then we'll be writing this fit function to train the neural network. I will also write the predict function. So feed forward, feed backward, and update weights. Maybe we can put it for the next session. So yesterday we had this main function where we read the CSV file with the help of DS helper and we got this X, Y, and the number of classes. So total number of observations and input features are nothing but they are the x dot shape. So what is this x dot shape? This is 210, 7. I hope you can recall. So from this, we got the number of observations, then the input features. Moving ahead, so we got all indexes, then we got the fold indexes, then we iterated in the folds through this loop here, and we kept on getting the training indexes by deleting the test indexes from all indexes, and thereafter we did our train test split on the data set. So we created our model. Now this is the code which we are going to work today on, right? So line number 197. So when you're creating a model, that's like your ANN, you got input features. Input features are 7. Number of classes which are output, they are 3. And in the hidden layer, I am going to take 5 perceptrons, right? So there's only one hidden layer. Now, if there are 2 hidden layers, you could have said 5 cross 5. It means that the first hidden layer is going to have 5 nodes, 5 perceptrons, and the second hidden layer will have another 5 perceptrons. But as of now, we have only one hidden layer. So we're gonna work on this structure today, right? So rest of the things we not are gonna touch down here and there. So we're gonna work majorly on this ANN part. So model.fit, we will train the model with 25 epochs. It means for your 4 folds, and we're gonna come up and manage the training with 25 iterations each. And for every fold where we are training the model with 25 epochs, we're gonna have a prediction on the training data and on the testing data. Based upon that, we are going to come up with our accuracy scores, right? So wherever your training will match the prediction, right? So we're gonna sum up, divide by the length, multiplied by the 100. So you will get your training and the testing scores, for which 4 folds we are appending the data in these lists, and after this loop is finished, you just take an average of your accuracy scores, right, over the training and over the testing. So guys, this was something which we did yesterday, a very quick introduction to what we done yesterday. Now today we'll see how we have to create the model. Let me copy this. So I'm just going to come here and comment this part. So I'm just commenting everything here, if you can see now. So let us try to focus on what is meant by creating the model here. Now we got these input features, or other way around, what I'll do is just give me a moment so that we can use some of the code snippets from our data set. I'll just not start iterating here. So I have not iterated and part of kind of use this model. So coming here, what if you try to write this guy, right? So creating the model. So there are 7 input features. There are a number of classes which are 3 which we want to predict, right? So this becomes your output, right? These are targets, basically 3 targets, and I am having this hidden layer of 5. So hidden layer is like 5. It means what? Only one hidden layer with 5 nodes. There may be a case that if you would have taken 5, 5 and 4, it means we got 3 hidden layers with first having 5 nodes, second having 5 nodes, and third having 4 nodes. So in case, right, in case you would like to have more layers in your network, so this may be an approach. Guys, can I get a smiley here from all of you as an acknowledgement on this part? So what is input feature, output feature, and this hidden layer? So this part of our discussion on how many hidden layers there should be, that is pending, right? But at the same time, we are just going to understand one algorithm, how we can write an ANN. At the same time, guys, there is one more discussion which is still pending, right? So number of nodes in the layer and how many hidden layers you want, right? So it's all about the hidden layers. Input features and the output features, they are perfectly decided for us, okay? So that way we are already relaxed. Now, the number of layers which you are going to introduce in between, for that, we'll just have another discussion. So as of now, we understood that if there is a layer where you have written as 5, it means one hidden layer with 5 nodes. And if there is a list, it means that you got 3 hidden layers where this 554 represents the number of nodes. So let me come here and show you what we are supposed to do. So we got these input features, which are 7 here for us, right? If you will see seeds.csv, so this x1 till x7. So this is what we got in our very first layer. So these are our kind of layers. So guys, what we'll have is we'll have these neurons in our very first layer. So this layer is going to act as an input layer for me. So why this is going to be an input layer for us? This is going to have these x1 to x7, right? So I'll just write down these neurons here only, right? So this is x1 for x1. This guy will be for x2, for x3, x5. This is x6. This is your x7. So these are the kind of neurons, right, which we have as in our, let's say, as in our inputs, right? So x1 till x7. Now in my hidden layer, what I got the similar set of neurons, but they are 5 in number. So this is our hidden layer, and sort of h1, h2, h3, h4, and h5, right? So these are the another set of neurons available in our layers, and our final discussion is on the output layer, where we have these 3 of them, right? So this is O1, O2, and O3. These are the 3 output neurons, right? So this is where we are going to take the predictions, right? So there will be predictions on the basis of these, right? So we'll be getting one output, right? So basically, you are not targeting the softmax function. You're targeting something known as sigmoid here. So here you are going to get the output, right? Now, what we have is we have these certain inputs, right? This x1, then the x2. Just give me a moment here. I'm just gonna use this across. These are the particular inputs to your neural network. So this very first layer is your input layer, right? So I'm just gonna write it here. So this is your input layer. So the layer is named as the input layer. This is going to be your hidden layer. And this guy is your output layer. So from this input, what we're gonna have is we're gonna have connections to this hidden layer, right? So this H1 will be given as an input, which will be the output of all these nodes coming to this fellow, just like these guys, right? And of course, this will continue for each and every other layer as well. Same way for this guy O1. So you're gonna have these inputs coming in from all the nodes of the hidden, so that this guy can actually make up a decision. So this is how the neural network is going to be connected, and I hope this part is clear to everyone how this is going to work for us. Can I get a smiley as an acknowledgement? I hope this is clear to everyone what we have to do. Now, this entire network is a list of 3 layers. If you see now, it's a list of 3 layers. So we got first layer as input layer, second layer as hidden layer, third layer as output layer. So it's very simple for me to understand that I have to create a layer which will have nodes, right? So in my session 60.py, when I'm giving these input features, this is the value 7, number of classes is 3, and hidden layer is 5. So we are trying to build this neural network, exactly the same. But we have to somehow ensure that the output of someone goes as an input to someone, right? So what I'll do is, I'm gonna come here in my ANN class. So this network is an empty network as of now, right? So this network is what? It's gonna be a list of layers where every layer is a list. I hope this is clear, right? So list of layers. This network is going to be a list of layers where every layer is a list of nodes. Can I get a smiley once again? I hope this part is clear again. So we got network in our current ANN model, right? So we want 3 layers, right? So input layer, hidden layer, and the output layer. So we got this list of input layer, output layer, and the hidden layer. So where input layer is going to have further, so your input layer is going to have 7 neurons. So this input layer is basically representing N1, N2, N3, N4, N5, N6, and N7, right? So this is how we have these different nodes or neurons. In the hidden layer, you got these 5. So it's basically a list of lists for me. And in the output, I got these 3. Right? So this is what we have to do here. Now the next thing is where we'll define one function called create layer. So this is going to create and return the layer for me. But I'm just going to take 2 parameters, right? So that's like your layer 1 and the layer 2. So what I'm basically kind of expecting is in the layer 1 and in the layer 2, right? So how many number of nodes you gonna have, right? So nodes in layer 1, and I'm gonna take nodes in the layer 2, right? So how many nodes you have in the layer 1 and how many nodes you have in the layer 2, and I am going to somehow connect these nodes. So we yesterday wrote this import random. So what I'm gonna do is in my create layer, so I'm gonna say random dot seed of 1. Now let us create a layer which is going to be an empty list to begin with. Now I'm gonna say for I in range. So guys, in the range, I'm gonna say nodes in the layer 2. So there are some nodes in the layer 2, right? So the next part which I'm going to do is there are some weights. So there are some random weights because your layer is definitely going to have an input, right? So if you want, you can just mention this guy as input and output if you want to be more want to decide it in a more easier approach. So I'm iterating in the range of output, right? And weights is going to be a list. So I'll choose this random dot random, let's say for underscore in the range of input. So what I did, so we created weights, random weights for inputs, right? So this is like one weights as a list which is random for your inputs. Now what is node? Node in the list is going to be a dictionary, or you can even create this guy as a perceptron, right? So I'm having this as a dictionary here. So this guy is going to have weights as the first key. Then who is the output? What is the output exactly? So as of now, we don't know the output, so we're gonna keep it none. And the third parameter is a delta for your back propagation algorithm, right? Then I'm going to say layer dot append the node. So what we did, basically we are going to iterate in this range of output, and based on the input we're gonna have these weights, right? And thereafter we're gonna append the data into the layer, and finally we'll say return back the layer. So you return back this layer for me. So this is one more function, right? So creates a layer with nodes. So can I get a smiley? Is this function clear to everyone? I hope this is not a big time challenge for us. So random dot seed 1 means that we're gonna start. This is the start for generating the random weights, right? No Shilpa. So what happens is when we actually try to generate random numbers, you need a seed, the number from where you want to begin, right? So that we can generate the random numbers. And every time when you use the random dot seed 1 now, so it will always treat to generate the same sequence of random numbers when you keep the same seed. This somehow we discussed as well during our k-fold validation. If you can see, Shimpa, this we already have covered. Okay, anyways, so let's now proceed. So guys, in my ANN init function here, so what I'm gonna do next is let's come here and actually build this network, right? So I'll say self dot network dot append. So I'm gonna append the very first layer. So that's like your self dot create a layer. So I'm gonna create a layer with the self dot input, comma, self dot hidden of 0. I hope this makes a sense to everyone. So we are trying to make a layer between input and the hidden 0. If you see here, so between the input and the hidden 0. So we have only one hidden layer, right? So that is why I'm using this hidden 0. So hidden of 0 means there should be 5 nodes. Guys, I hope this is clear to everyone. So the next layer which we have to make is your from hidden to the output. Dynamic algorithm to create the layers, right? So the next one, we already know that what we need to do, right? So we need to just go from now the hidden to the output. But what I'm saying is, if we write a dynamic algorithm to create this program, right? So how it's gonna go? So in case the length of my hidden layer is equal to 0. Let's say you have no hidden layers, right? In case we have no hidden layers, then what, right? There may be a use case. So we say self dot network dot append. So what you want to append? You want to say self dot create me a layer, and this layer is going to be just between the input and the output, right? So this is in case. So in the else case, there are hidden layers. In case we have hidden layers. So we are not going to write this algorithm in a very static way, right? So we are making it in a dynamic way that, okay, there may be no hidden layer and there may be many hidden layers. So we don't care if there are many hidden layers, but for multiple hidden layers, the very first hidden layer is going to be created between input and the hidden of 0. If there are, let us assume, if there are multiple hidden layers, right? So coming up to my next, I'm gonna write a loop here. So for I in the range, I'll start from 1 and I will go till the length of this hidden layer. So that's like your self dot hidden. So what we did, remaining hidden layers, we are going to iterate in remaining hidden layers. All right. So we're gonna iterate in the remaining hidden layers, and we'll just say your self dot network dot append. Let us append what? So you now keep on appending self dot hidden of -1 with the self dot output. And guys, sorry, this is my bad, not -1. This is going to be I -1 with the hidden of I. Makes a sense, guys? Can I get a smiley here? So what you're doing is hidden of I -1 with the hidden of I. You are basically trying to append the layers. So an acknowledgement awaited. I hope this is clear to everyone. This algorithm is clear to everyone, this for loop. And once this for loop is terminated, right? So the last hidden layer, whatsoever is the last hidden layer, right? So in the network, I'm gonna append the last hidden layer. So how you will get the last hidden layer? So guys, it's gonna be self dot hidden of -1. That's like your last hidden layer with the output layer. Now this is one generic algorithm which we have written to create list of lists, right? For every list, you're gonna have a node representing weights and the outputs, but outputs as of now are none for us. And there is a delta which will be maintaining for updating the weights in the list. So let me share this entire program as of now with all of you. So if you have any query or any challenge, you can please raise the same. Share it over the chat. Please give it a review and let me know if you have any query, guys. So before I return the layer, I'm just gonna say print. This is from your ANN. Created the layer, and let's say between input and output, right? So we'll just get this part here for us. So we have these two connections basically, right? So coming up here as two connections, right? So input connected to hidden and hidden connected to the output. So this is what basically we are trying to somehow come up and maintain this part. So you have this input layer connected to the hidden layer and hidden layer connected to the output layer. So this is what we are trying to maintain, right? Step 1 and step 2. So this is what we have to do, 1 and 2. Okay, so we have a query here. So Shimpa says hidden I minus 1 with hidden I. So Shimpa, let us say that you have 3 hidden layers, right? So assuming you get this part here as this 5, 5 and 4. So how your I will iterate? So I minus 1 should be connected to I. So next time this becomes I minus 1, this becomes I, right? So we're going to connect these hidden layers. So good to go. And once all these hidden layers are internally connected, right? So the last hidden layer must be connected to the output layer. So anyone having any other query, guys, can please raise the same, right? So we got this very basic way of creating the layers with the help of lists. So this way you are having a network which is a list of lists for us. Now next what I'm gonna do is I'm gonna work on something known as your fit function, right? So the fit function and the predict function maybe. So this guy takes x, y and he pokes, right? So once you are done with the model creation, so let us try to run this program actually. So model created, model details input 7, output 3, hidden 5. So model network initially is this list with 0. So we created the layer between 7 and 5. Then we created the layer between 5 and 3. So what I'll do is I'll even print this network afterwards, right? So once you have created this model, so in the loop here, so what I'll do is I'll just say for layer in model.network print the layer, right? So let us try to print all the layers here. Or what I can do is printing of layers can be taken as a function here in the ANN itself. So define print network. So for layer in self dot network print the layer. So we'll come here and we'll say model dot print the network. So let's run the program here. So here we are, right? So this is your node 1. So every layer is going to have a node. So even I'll make it more better. So this is, so layer is basically a list of dictionary, right? For node in layer. Print the node, and once this is done, I'm just gonna print this part here. Once okay, so to make it more better, so for so I think printing layer details. So we'll make it more effective, right? So this is your first layer details, where we have these 0, 1, 2, 3, and 4, right? So total 5 nodes. Node 1 with the list of weights. Output is none, the delta is none. Then the other layer is going to have these 3. So input, we already know that this is going to be 7, right? So these are the details, right? So we got 7, 5 and 5, 3. Guys, can I get a smiley now? So this is, I think, one basic way where we understood that how we can create the layers, and we can work accordingly in the ANN part. Wonderful. So now what we're gonna do next, right? We're gonna write this function called fit. Now for my fit function to work, right? So we depend upon epochs, right? So epochs is the iteration with which you're going to work, right? So for epoch, in epochs, so I'm gonna iterate in n number of epochs to train the model. So next is what? In order to come up and kind of iterate here, so I'll just come and write another for loop. Now this is basically we have to just ignore time complexity here. We can write some more better algorithms, but this is going to be order of n square, right? Fit function is going to be order of n square. So for x comma y, and I'll say in zip me this x comma y, right? So what we are doing is we are trying to zip our labels and features together. And once we are done, so the first step in our training should be feed forward the data, right? So I'm going to come here and write self dot feed forward, right? And in the feed forward, I'm going to pass this guy called x. So it means what? The feed forward function is going to take some x as input. All right, guys. So this guy is going to take some x as input. Now, what should be the role of feed forward? Now, for layer in your self dot network, So we are iterating in the layers. In the feed forward function, you iterate in the layers. So you're gonna iterate in the layers. So for layer in the self.network, I'll create one output as a list, right? So there is a list of some outputs. I'm just considering this as output. Now for node in layer, so you're iterating node by node. So node is going to have one key called output. If you will just remember, so we created this output as one of the keys in the node. So I'm going to say in the layer you have a node and the output of this node is what, right? The output of this node is going to be submission and then the activation function, right? So self dot sigmoid activation of self dot submission. So submission of what, guys? So in the submission there are two things. One is the inputs, another one are the weights. So inputs is going to be your x and weights is going to be your node having the weights. Let me simplify this before we make it more complex. So there is this summation. So sum is summation of x inputs and weights which we randomly created right here, which we randomly created. So this is one input list, this is one list of random weights. Now you pass this sum into the sigmoid function and you get an output which you are storing at node of output. At the same time, what I'm going to do is I'm going to say output dot append. So append this output in this list here. And then what we are going to do is we're going to say that let's say, so you now just want to come out and return this list, right? So these kind of guys, this x over here is after this for loop, right? I'm just going to say x is going to be the output. So what I did now basically, so now we are making x as output, which in next iteration serves as input to the next layer. Very important point here. And whatever will be the final value of x, right? So we'll return back from this function called feed forward. So let us see what we did. Now for epoch in epochs, you got this xy, right? So if you can recall in our yesterday's discussion, if you can train your model, so how you'll train your model now, right? So this is your model.fit. So you got the training data, x train, y train, and the number of epochs, if you can recall. So this is where we did, right? X train, Y train, and epochs, right? So you created these 4 folds. In the first fold, you will have the training data for X and Y. You're passing this training data for X and Y here in your ANN to your ANN. So you got this X and Y coming here with the number of epochs. So you zip your X and Y so that you can create a complete list in this manner. So this is your X and this becomes your Y, right? So what we do, we feed forward this guy X. When you feed forward this guy X, right? So you are iterating in the network. In the network, you are finding and evaluating the sum at each perceptron with the sigmoid activation, and you are appending this in the output layer. And now this output layer will become the input to the next layer. So what whatever will be the last part, right, that will be returned. So final output of the network shall be returned back. Guys, a smiley awaited from all of you. I hope this is clear to everyone. So the algorithm is clear to everyone. What is this feed forward? So typically, whenever you go for your ANN, so one of the most important things is that how you're gonna do a feed forward, right? So your input goes to this H1 to this input perceptron, and this output becomes the input of H1, right? So that is what we are trying to do here. Now, in the next discussion is what we have in our next discussion, right? So I'm gonna implement this guy called one hot encoding. So I will take two inputs here. One is the index, and another one is your output, right? So in the one hot encoding technique, so I'm gonna say x is some numpy dot zeros. I'm gonna create an array of zeros, and this array of zeros will be created based on the size of your output, and let this data type be integer, right? So we want integers only. Why integers? Because your classes are integers here, 1, 2 and 3. So this one hot encoding, what I'll do is I will say x of index is equal to 1 and let others remain 0. So return this guy x. So what we did here, we created one numpy array with every index as 0. So if you have an output size of, let's say, 7, if you have an output size of, let's say 10, right? If there is 10, so what we did, we made numpy zeros of size 10, but all those indexes which we are passing here, that will put as 1. So the one hot encoding scheme. Now, in order to come up and do some predictions, right? So why I need this? So let us see that as well, that why we actually are working on this guy, right? So one hot encoding. What is the main reason for one hot encoding to be in our picture? So coming here in your fit function, so I'll just create y one hot is equal to your self dot one hot encoding for y and the output. Guys, if you will observe, so we have an output layer. So based on the output layer, so you got this y layer, the current y layer, right? The current y layer here. So you are converting it into ones and zeros. So what will happen, wherever your class will match, you will get the value 1. Wherever the class will not match, for example, for this observation, you will get this guy as 0. In case y is 1, right? So these records will have your class labels as 0. Same way, wherever you will find 3, the class labels will become 0, right? So we are making it more easier to do the predictions. Now, once this is done, right? So once you got this target available in your, so this is your target converted into one hot encoding. That is where we have target, it will be 1 and otherwise 0. Guys, I hope till here we are good to go, right? So we converted this target into one hot encoding scheme. So why is this important for us? So what I'm gonna do is self dot feed backward. I'm just gonna pass this one hot encoded data into my feed backward function. So we will implement this tomorrow, right? And once I'm done with this, so thereafter I'm gonna do update in the weights for X. For input, I'll just do an update in the weights, right? So backward passing of the network will work, and thereafter we're gonna update the weights in this X, right? So these two implementations we'll do tomorrow, not now, right? So anyone with any query here till now? So I hope this one hot encoding is clear, and the print network is also clear to everyone. An acknowledgement awaited from all of you. So I can write this predict function. Prediction is quite easy to write. So there will be y prediction, which is going to be your numpy dot array. So guys, what I'm gonna do is I'm just gonna create first of all a list. So just give me a moment here. So I'm gonna create, let's say, predictions is going to be a list, and this list is going to be your self dot feed forward. You pass X as input, and this is going to be for X in your X. So you take input, right? And you got this guy, but here we got this list of predictions, and we know we can use np.argmax, where I'm gonna pass this list of predictions, and I'm gonna say choose the data type as, let's say, np.integer. So this is your y prediction, and what I'll do is I'll just simply return this y prediction. So just give me a moment here. Return this y prediction. So this is your prediction function, right? So we'll when we'll do self dot feed forward. So feed forward function is going to give me some final output, right? As in this value of X, right? And thereafter, once this is returned back, so you are going to have a list of the outputs, and from the outputs here, so what you will do is you will just pick up the max from the predictions based on the integer data type, and you're gonna return it back. So fit function is going to train the model, and predict function is going to give us prediction for a particular input, right? So of course, yes, when I'm going to make predictions, right? So at that time, your network would have been trained and your weights would have been updated. So guys, thereafter, in the end here, so we are left with now only two functions called feed backward and update weights. So are we good to go here, guys? Can I get an acknowledgement from all of you? So we have just left the two functions. So this we can take up in another discussion. So till here, I would request all of you to go through in details, right? Because now we'll be left with only feed backward and update weights. Now for this, there is one prerequisite. So please study the blogs which I shared over the group, right? So please try to just kind of study the blogs which I shared over the group, so that it becomes easier for you to understand that how you're gonna write a feed backward and an update weights function. Okay, so also try to figure out your sigmoid and sigmoid derivative. So Shimpa, these are the mathematics. So majorly we got rectified linear unit. So I think we did, guys, we did the activation functions. I think we did those 6 activation functions in our very first session, right? So there is one small query here. So where to use which activation function? So typically when you have to come up and kind of you can say work on classification, we'll work with softmax because it's gonna give me so many probabilities, right, for my you can say various classes. But at the same time I can even work on sigmoid, right? Sigmoid can also be used. Now every mathematical function has to be chosen wisely where to put what. For an instance, if I am doing regression, I may go for rectified linear unit, right? So what I'll do is I'll even come up and share another part here where you guys can always figure out that, okay, if I have a certain type of classification problem, so I can use these sigmoid and the softmax, or if you have any other thing here and there, so you can try to use any other activation function. But in our ANNs, we majorly focus on 3 activation functions, guys, right? That is like your rectified linear unit, majorly for the regression and for the classification parts, then the sigmoid and then the softmax. These are the 3 major important activation functions. So we have a query here. So how to split the data set for training and testing where the last column is not like target variable. So Shimpa, if you don't have the last column as your target variable, are you trying to say that you don't have a target variable in your data set? So if you don't have a target variable in your data set, then you're not doing a supervised learning approach, right? So you don't know what you're trying to predict. If you don't have what you're trying to predict, so why you wanna train and test? I hope this query is clear, right? You have no data to predict, you have no target. Why you want to train and test? Why you wanna split, right? So here you have to implement something like K means clustering, where you divide your data into multiple classes and then you give the labels. So it's gonna be an unsupervised learning approach. All right, guys. So this is going to be all for the day. So thank you so very much. Have a wonderful time ahead. So we'll be. I'll just push this program over the part. So Monday we're gonna wrap up our ANN model. This is the part 3 of ANN in making. So Monday this program will be finished, and Tuesday we're gonna work on something known as your convolution neural networks. So we are on the agenda of image classification very soon, but will not be coding every ANN in this manner, right? So thereafter we'll always be working with the Keras or the PyTorch APIs. Thank you guys. Have a wonderful time.